In this problem, we are given that the arithmetic mean and the geometric mean between two numbers are in the ratio m is to n. So we need to show that the numbers are in the ratio as given here. So let's begin. So we will specify the two numbers. So let the two numbers be. So the arithmetic mean, we are denoting it by the letter A. So this will be equals to A plus B divided by 2. And the geometric mean, which we will be denoting by the letter G, that's equals to square root of AB. Now, we can rewrite this equation as A plus B equals to 2 times A. And AB will be equals to G squared. Now, using these two equations, A plus B equals to 2 and AB equals to G squared, we can form a quadratic equation. Now, we suppose that A and B be the roots of a quadratic equation, such that the equation will be represented as x squared minus A plus B times x plus AB equals to 0. Then we already have obtained the value of A plus B, so that will be 2 times A x plus AB will become G squared. So this is equals to 0. So this is a quadratic equation and we can solve the values for x. So x will be equals to negative of negative 2a. So you're using the standard formula for finding out the roots of a quadratic equation. We have negative of the coefficient of x, which is negative 2a, plus or minus square root. So within the square root, we'll have to find out the discriminant. So that will be coefficient of x, which is negative 2a squared, minus 4 times the coefficient of x squared times g squared, whole divided by 2 times the coefficient of x squared. So this is going to give us the value 2a plus minus, underneath the square root, we're going to have 4a squared minus 4g squared, whole divided by 2. So now we're going to get 2a plus or minus 2 multiplied to a squared minus g squared whole divided by 2. So we get a plus or minus square root of a squared minus g squared. So this is the value of x. So these are the two roots, and we have already specified that a and b are the roots of the quadratic equation. Hence we can say that a value, so our a will be equals to a plus square root of a squared minus g squared, and b will be equals to a minus square root of a squared minus g squared. Fine. Now, it's also given in our problem that the ratio of the arithmetic mean to that of the geometric mean, so that's equals to m over n. Fine. So since it's a ratio, we can take it to be equals to some constant lambda, say. So here lambda is some constant. So that means we can rewrite this ratio as a over m equals to g over n equals to lambda. So a over m equals to lambda, that's going to give us a equals to lambda m, and g will be equals to similarly lambda times n. Now, the reason why we've done this, because we want to find out the value of the roots. That means a over b. So a over b, we have already found out this value. That's a plus square root of a squared minus g squared divided by the value of b, which is a minus square root of a squared minus g squared. We will substitute these values into the ratio. So we have, so a will be lambda m plus square root of a squared. So a squared will be lambda squared m squared minus g squared. So g squared is lambda squared n squared whole divided by lambda times m plus and square root of lambda squared m squared minus lambda squared n squared. So this will be equals to lambda times m plus lambda multiplied to m squared minus n squared whole divided by lambda times m plus lambda times, so there's a negative sign here, negative m squared minus n squared. So we're going to get m plus square root of m squared minus n squared whole divided by m minus square root of m squared minus n squared. So this is what we were asked to show, that the ratio of the two numbers a and b, that's given by m plus square root of m squared minus n squared divided by m minus square root of m squared minus n squared. Hence proved.